question in this exercise. Question number 14. 1.2 meter tall girl spots a balloon, and the balloon is actually leaving that person, and the height of the balloon from the ground is 88.2 meters from the ground. Okay. Girl herself is 1.2 meters tall, so that means the effective height from the eyesight level is 88.2 minus 1.2, so that will be 87 meters from her eyesight level. And remember this point because we are going to use this number in the solution. The angle of elevation initially has been given as 60, and after the balloon travels, the angle of elevation reduces to 30 degrees. We have to calculate the distance traveled by the balloon. So let's quickly see the diagram. Let's say this line represents the eyesight level, not the ground level, because we have already subtracted 1.2 meters, and this line represents the net elevation, the effective elevation from the eyesight level of that balloon. So that would come out to be, now this will be obviously perpendicular to the ground, and this is 87 meters from the eyesight level. So the angle of elevation in the beginning has been given as 60 degrees. After a while, the balloon travels away from the girl. The girl is here, the balloon is here, and the new angle of elevation with the same 87 meters height has been given as 30 degrees. 30 degrees. So we have to calculate basically the distance traveled between these two positions. So we have to calculate distance from position 1 of the balloon right here and position 2 of the balloon right here. So let's assume that the initial distance, horizontal distance, is x1. The actual distance traveled by the balloon is x2. And let's see how we can solve this question. So first we are going to see the triangle closer. Always we see the smaller triangle first, closer to the right angle triangle, which involves like simpler variables. So let's say if we consider this particular triangle, tan of 60. Why? Because we are, for this 60 degrees, this 87 is opposite and this x1 is adjacent. We are correlating opposite with adjacent. We are going to use tangent trigonometric ratio, which is tan 60 degrees, which is opposite over adjacent. Tan 60 is root 3, and we are going to see opposite is 87 and x1 is unknown. We can exchange x1 with root 3. So x1 goes here, root 3 comes in the denominator, and we can write x1 is equal to 87 root 3. Now the denominator is irrational involving square root. So we'll perform rationalization, which will eventually help us in addition or subtraction. So we are going to multiply both numerators and denominators by root 3. So if you do that, you will get additional root 3 in the numerator, and this root 3 will eventually become 3. 87 can be divided by 3. So the x1 value will come out to be 29 root 3 meters. But that's not what we want. This is this particular x1 distance related to original position. We want to calculate how much distance was traveled from position 1 to position 2. We are interested in x2. So for that, we will now consider second triangle, and that would be involving still 87 as the opposite side. Now the angle of elevation has been given as 30 degrees, and the adjacent will be x1 plus x2. So now we will write a generic expression, tan of 30 degrees opposite over adjacent. We are still correlating opposite with adjacent. Tan 30 degrees is 1 over root 3 standard value. Opposite is still 87. Now the adjacent is comprehensive, complete x1 plus x2. Now out of that we have calculated x1. So we can replace that right over here, and we can cross multiply and then replace if you want. Now x2 can be calculated by transferring this 29 root 3 over the other side, and the final answer will be 58 root 3 meters, and that will be the distance the balloon has actually traveled from position 1 to position 2. That will be this dotted line distance.